Good morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today, in this session, I want to explain about eccentrically loaded riveted joints. So up to now, we have seen the normal loaded riveted joints. But in this session, we will learn eccentrically loaded. So what do you mean by eccentrical load? And how to calculate this type of loads, loads, and how to calculate the dimensions of the rivet. So when acting eccentrical load. So first of all, the eccentrical loaded riveted joints means when the line of action of the load does not pass through its the centroid of the rivet. So it means the action of the line of action of the force not coincide with the center of the rivet system. So thus all rivets are not equally loaded. So then the joint is said to be an eccentrical loaded riveted joints. As shown in figure, I will show you figure. So that load is called as eccentrical load, and the distance, at what distance the eccentrical load is acting, the distance is called eccentricity. So eccentrical distance that you can represent with small e. Clear? So these type of loads are called as riveted joints. Suppose example, if you take a rivet system having 4 rivets, but in an eccentrical loaded system, all rivets are not equally loaded. So at which heavily loaded rivet you have to identify, and at that the rivet, particular rivet, need to calculate the strength of the joint, and then finally you can calculate the dimensions of the rivet. Clear? So we will see in the next coming up slides. The eccentrical loading results in the secondary shear force caused by the tendency of the force, so the twisting moment. See, in this mainly 2 types of shear stresses will occur. One is primary shear stress and another one is secondary shear stress. The primary shear stress occurred due to the direct shear load. So, and secondary shear stress will occur due to the twisting movement. So, twisting movement, clear? So, twist joint about the center of gravity, clear? In addition to the direct shear. So, take here, let P is the eccentric load on the joint and E is the eccentricity. So, the distance between the line of action of the load and the centroid of the rivet system. Clear? So suppose your the one plate is there. The rivets are located like this. So this is our load acting line. So this load acting here, and with the center of gravity is located at the center of this plane. So now this is called as E. So the distance between the line of action of the load and the center of the rivet system. So this type of joints are called eccentrically loaded joints. Next, the procedure is there. So for design of eccentrically loaded riveted joints, so we will see the procedure. The first of all, see in this diagram shown, so bracket. So it has 4 rivets and the load acting at one edge with the distance E. So this is eccentricity. First of all, find the center of gravity of the rivet system. Clear? So the A is the cross-sectional area of the rivet, and x1, x2, x3 are the distances of rivets from OY, and y1, y2, y3 are yx. Suppose this is yx axis and OY. So what is the distance? So first rivet. So suppose first rivet it is. What is the distance from its the yx axis? Clear? That is y1. So what is the rivet center distance? y2. So this is y3 and this is y4. See, so like this need to specify the center of gravity points. So similarly x1, x2, x3. The distance of rivet from OY axis, the first one here, x1. Similarly, this one x2, x3, clear, and x4 need to specify. Next, here load is eccentrical load and E is the eccentricity. So first find out the center of gravity and then draw these two diagrams. So one is here acting direct shear load and another one is direct shear load and secondary shear force and finally resultant shear load. So at one rivet here the two forces are acting. One is PS and another one is F1. What is F1? Here F1, F2 and F3 are F4 and F3 are secondary shear forces due to twisting movement of this load about its center of gravity. Clear? So the PS is the direct shear load. So that is the direct shear load. You can calculate direct shear load, shear strength, shear force that is equal to direct shear load by number of rivets. Suppose here number of rivets are 4. The load by will R P by N. Here load is given P and number of rivets. You will get direct shear stress. But secondary shear stress due to the twisting moment. So no, you can't calculate directly. So that's why. So draw this diagram and take their moments and finally find the secondary shear stress. Clear? So L1, L2, L3, L4 are distances from its center of the rivet to its center of gravity. What is the distance of first rivet? First rivet center, that is L1. And similarly L2, L3, L4. Clear? And finally need to draw this F1 and PS diagram and find the resultant shear stress. So at which rivet is heavily loaded, identify. Second one is introduce two forces P1 and P2 at the center of gravity. So these forces are equal and opposite to P. So already shown in this diagram. P1 and P2. Assume that all rivets are of the same size. Clear? The effect of P1 is equal to P is to produce a direct shear stress. So already I told you. So therefore, direct shear load on each rivet is you can calculate by using this relation P by N. So acting parallel to the load P. So next, the effect of P2 is equal to P is to produce a turning moment. The effect of P2. So P1 is direct shear stress P and P2 is produce the turning moment of magnitude P into E. So which tends to rotate the joint about the center of gravity in clockwise direction. Clear? So due to the turning moment, the secondary shear stress on each rivet is produced. So in this the secondary shear load case, the following two assumptions are made. One is the secondary shear load is proportional to the radial distance of the rivet under consideration from the center of gravity of the rivet system. The direction of secondary shear load is perpendicular to the line joining the center of the rivet to the center of gravity of the rivet system. Two assumptions are made while calculating secondary shear load. So F1, F2, F3 secondary shear loads on the rivets 1, 2, 3, etc. And L1, L2, L3 radial distance of the rivets 1, 2, 3, etc. from the center of gravity of the rivet system. For assumptions, first assumption, the force F1 directly proportional to L1 and F2 directly proportional to L2 and so on. So take this relation F1 by L1 is equal to F2 by L2 is equal to F3 by L3. So you can calculate F2 and F3 relations. F2 is equal to F1 into L2 by L1 and F3 is equal to F1 into L3 by L1. So you know that the sum of the external turning moment due to the eccentric load and the internal resisting moment. So the internal resisting moment of the rivets must be equal to 0. So that is P into E is equal to F1 into L1 plus F2 into L2 plus F3 into so on. Clear? So this is, you can write in terms of L1 square, L2 square and L3 square. Clear? So now from the above expression, the value of F1 may be calculated and hence F2 and F3 etc. also known. So the direction of these forces are at right angles to the lines joining the center of rivet to the center of gravity of the rivet system. As shown in figure, I will show you in clockwise direction or anti-clockwise direction about the center of gravity. So it gives the turning moment P into E. So next, the primary or direct and the secondary shear load. So may be added vectorially to determine the resultant shear load. So calculate the resultant shear load. So P direct shear load P square plus F square and 2 PS into F into cos theta. So here this PS is the primary shear stress and F is the secondary shear stress. So angle between these two theta. So then you will get resultant shear stress. The angle between the primary and direct shear load as shown in the figure. So when the secondary shear load on each rivet is equal, so then here one thing you have to do. So which rivet is heavily loaded, you have to identify. So heavily loaded rivet will be one in which they include angle between the direct shear load and the secondary shear load is minimum. Clear? So the maximum loaded rivet becomes the critical one for determining the strength of riveted joint. So which rivet is critically loaded. So we have to identify. So then use this relation and find this maximum shear load is equal to pi by 4 into d square into tau. So we will get a maximum shear load. Clear? So by using this relation, you can calculate the diameter of the rivet. Clear? Thank you. These are the references I have taken.
Like, share and subscribe. Hit the bell icon for more updates.